This case study involved an underground concrete tank located in Devil's Tower, Wyoming. The tank, located on a big hill at the base of Devil's Tower, had begun cracking, leaking due to excessive corrosion. The tank was rehabbed using Raven AquataFlex 506, Raven 760 HPPC, and Raven 171 FS. Located 473 feet above the maintenance area of the Park Service and approximately halfway up the side of the foot of Devil's Tower Park camp areas, this 50,000-gallon potable water tank was built approximately 70 years ago to service both areas, including campsite restrooms, fire hydrants, visitor center, and the maintenance area below. This tank was showing signs of mild to moderate corrosion on the concrete walls and also had cracking of the concrete floor, which were thought to be leaking. Initial estimates to replacing this old tank with a new structure were over $1 million due to the difficult location of the tank, disruption to a national park by road renovation for new large equipment to build the tank, following U.S. National Park Service guidelines throughout the new build process, etc. Due to these complications and cost, installing a lining in the existing tank was a viable option. Upon reviewing the inspection of the tank with Bearco Construction, general contractor for the project, a flexible lining alternative to the original specification involving a quick return-to-service epoxy system was suggested. Another big concern for the Park Service is that the tank couldn't be offline for any longer than 7 days from start to finish. With these factors in mind, an NSF-approved flexible polyurethane lining system was selected, which could be placed into service in 24 hours or less after final installation. The tank walls, floor, ceiling, and concrete beams were abrasive blasted to a CSP5 profile. Abrasive blasting revealed concrete imperfections up to 1 inch deep. Spent abrasive was removed and the surface was cleaned to a dust-free surface. All bug holes and surface imperfections were filled with an epoxy polymer concrete as needed throughout the tank. To address the cracks present, a flexible hand-applied liquid membrane was applied in and onto the crack and up to approximately 2 inches on either side. While wet, a 9-ounce fiberglass mat, cut to size, was placed over the crack to bridge it and then completely saturated with the liquid membrane and left to dry. Approximately 2 hours after the epoxy mortar was used, a 100% solids penetrating epoxy primer was applied by roller at 6 to 10 mils DFT over the entire surface. The penetrating epoxy primer was used to lessen outgassing of the finish coat of polyurethane. The epoxy primer was allowed to cure overnight before the flexible polyurethane lining was applied. The following day, the 100% solids elastomeric polyurethane was applied by heated plural component airless equipment at 100 mils DFT over the entire surface. Approximately 4 hours after the application of the polyurethane lining, the entire surface was checked for pinholes/holidays by high-voltage spark testing per ASTM D4787. The tank was sanitized for potable water service and placed into service immediately. The cost to replace with a new tank was estimated at $650,000 plus difficult uphill site work. The cost to rehabilitate was $99,000, which included repaired cracks and new liner. The net savings was $551,000. Additional savings and benefits included minimal disruption of the environment and national park, fast return to service for fire and potable water, installation of a high-performance flexible coating to allow for freeze/thaw movement, and improved drinking water quality.